61. My bad. 61. Okay. When we do this, it allows us to use this power rule property that we learned in 6.5, where we get to expand the log by taking this exponent and bringing it to the front to multiply with the rest of the logs. Okay. So when I do that, it allows us to kind of like isolate just the x aside without changing any of the values. So that's going to be x times log of 2 equals to log of 61. Okay. Now, how do I isolate the x? Exactly. So that allows us to do this. Divide both sides by log of 2. Okay. That becomes 1. X is going to equal log of 61 divided by log of 2. That's what you put into your calculator. Okay? So be careful with this. Make sure you guys put close the parentheses after 61. Okay? So hit log. Log is next to button for number 7. Sorry, I laughed. Okay. Log of 61, close the parentheses, divide by log of 2. Okay? And you should get a very long decimal number, yes? Yeah. What do you mean? Yes. We need to, rounded answers may not produce the exact same answer, but will be very close is what it says, but I'm going to teach you how to get the exact answer. Okay? So you need to round to the nearest 10,000th place. Which means it's 0.1234 places after the decimal. Does that make sense? Okay, so I would have x is about, because it's not exact, we're going to put 5.9307. Leave it like that. Okay, I already took a video of this in 3rd period, so I'm not going to take another video, but I'm going to walk you through it. While it has the answer on the right bottom side of your screen, go ahead and hit STO with an arrow on it. It looks like this. STO with an arrow on it. Sorry, that looks like a C. STO with an arrow on it. It's next to, it's like between 1 and 4 on the left. You see it? Hit store and it says, on your screen it should say A and S with an arrow to it. What that's saying is, what do you want it to store it as? That's what it's asking. So I'm going to hit this button, the X, T, theta, N button, the unknown, the variable button, which is next to the alpha button. Do you see it on your calculator? You could use alpha button and then choose any of the green letters that you want to place it in, but why bother with it when you have a variable button that's readily handy and you only need to save for one variable, right? So I'm going to hit X and then hit equal or enter, and it'll give you the exact same value that you had just stored it into. If you ever want to check what X value you have, you just press X and then enter, and it should tell you exactly what it's stored as, okay? So when you're checking, are you guys doing okay? No, what's wrong? Did you do log of 61 divided by log of 2? Do that first. Log of 61 divided by log of 2. Okay. I'm going to check for extraneous now. And I'm going to put 2 to the 5.9307 on my paper. Okay. That's supposed to equal 61. And you can check with the calculator if it is going to equal to 61. So you're going to do 2 and then use the up button or the caret button above the division sign. And then put X. Because I just stored a value for X, you can use the X here. Okay? And it's not going to give you an error, and hit enter. What did you get?
60.
Woohoo! We just checked. And it's correct, right? 61 equals to 61. Therefore, this is a real solution, and there are no extraneous solutions. Does that make sense? If I did put 2 to the 5.9307, it's going to be 60.9984 something something. Is that pretty close to 61? Yeah. Does that make sense? Okay. Any questions? What's up? Here, this, in here. You can, but like I said, the answer will be really close, but it won't be exact. Like I did that here, and it says 60.99 something. Do you see it? I put the exponent with the decimal, and then I get something really close to it, but I didn't get 61. So it's up to you. If you're okay with finding a value that's really close to it, go for it. Do it. No? No, this is just simply checking, right? If it's completely different, then you know it's an extraneous solution, right? Okay. Any questions? Megan, what are you doing? All right, here we go. Is the power with the unknown by itself? On number 4. I know some of you are shaking your heads no, but the exponent minus 7 goes together. So this is one power. Is this one single power by itself? This is not. Number 6 is not. Because minus 5 is taking away after you've taken the power of something. Does that make sense? Do you see the difference? Okay. So we're going to take log of both sides. Okay, 8 to the m minus 7 equals 2 log of 92. Then what do I get to do once I have log on both sides? M minus 7 gets to be dropped down to the mere mortals of the world here. M minus 7 times log of 8 equals to log of 92. Now what? I'm going to divide both sides by? Yep. Log 8 has to leave m minus 7. So I'm going to divide both sides by log 8. And then I'm left with m minus 7 equals to log of 92 divided by log of 8. Is the m by itself yet? Nope, not yet. So we're going to add 7 to both sides. Then we get m equals to log of 92 divided by log of 8. Then add 7. Now, which one goes first in order of operations? Division or addition? Division. So when you put this into your calculator, even without the parentheses, it'll automatically do the division first before it adds. Okay? If that plus 7 is actually on log of 8, then you would have to put the denominator entirely inside a parentheses to make it do the adding first with log of 8. Does that make sense? Do you understand the difference? So in this case, you just put it in exactly like you see it, log of 92, close the parentheses, divide by log of 8, close it, then add 7 and hit enter. What did you get? I think I kinda heard m is about 9.1745. Do I say on 5 or do I go up to 6? Say on 5 because the next number next to 5 is 2. 2 is less than 5, so you stay on 5. Okay? You keep the number as it is. Now, how do we check? We should store this answer in X and then hit enter so you have the exact same value entered into your X unknown. Then you're going to put it into the original, which is 8 to the 9.1745. 1745 and blah, blah, blah. And then you're going to subtract 7 from it and see if it equals to 92, okay? So let's do it. A raised to the x power minus 7. Make sure you put minus 7, not negative 7. Negative is in parentheses, and it's going to give you a multiplication sign, and then the negative 7. So make sure it just says minus 7. Hit enter, and guess what I got?
91.996.
Oh, I can tell you put it in the actual decimal, didn't you? Yeah? Did you put in the actual decimal? 9.175? 1745?
Was I not supposed to?
You can, but you just need to know that it's going to be very close to 92. It's not going to give you exactly 92.
So if I press the STO button,
Uh-huh.
that means
You're storing the exact value of log of 92 divided by log of 8 plus 7.
so it'll just run for me.
You won't need to even round it. It would remember all the digits, even past what you can see. So it'll use that exact value in for x.
But if I get this over 10 even 92, I'll still be right.
But if you fake it, like let's say this answer is wrong, and you put it in, and you get something that's wrong, but you force it to be 92 equals 92, I'll be checking because it's not matching. So if that's the case, you're gonna get dinged twice rather than just once for the incorrect answer. Okay? All right. Are we good?
Enter. And then 8 minus
Are you okay? Is Joseph okay? No, he's not. He's usually not okay. Okay. Is 7 to the nth power the power that has the unknown by itself yet on number 5? Nope. So what do? We need to get rid of the 4, and it's going to be by dividing by 4. Always check 148 divided by 4. Is it divisible? Yes. So I'm going to put 7n equals to 37. You okay? You guys sang your heart out today. I enjoyed it. You guys went up there for moral support? That was very nice of you. Take log of both sides. N is going to go to the front. Log of 7 equals to log of 37. Okay. These steps should be pretty easy, right? I think it's just a matter of getting to the end and making sure you followed all the inverse operations correctly. Now what? Divide by which log? Log of 7 on both sides. So I have n equals to, or is it about? I have a feeling it's going to be about. Log of 37. Is everything okay? I have about 1.8556 or 7. Is it 6 or 7? You have no idea how many different ways that people can try to estimate these. It should be 6. Don't look at the 5, look at the number next to it on the right, which is the 4. You have no idea. They look at this. They look at 3 numbers over. They look at Good luck. Okay. 1.8556. Let's go ahead and check. Store this number in X. Enter. There it is. And then we're going to put 4 times. So I'm going to put 4 and then parentheses. Do I need to show you what I'm doing on my calculator? Wow. Where am I? There it is. I put 4 And then I'm going to put, what was the base of that number? 7. And then raise it to x power. Come down to the normal land. 148. Did I do it right? Let me check. Bloop, bloop, bloop. There it is. 148. Yay. Okay, so 4 times 7 to 1.8556 is what I write. Does it equal to 148? And it does equal to 148. Yes. Did you use 1.8556?
Yeah.
That's why.
But I did the STO thing.
You did?
Yeah.
Okay, let me see.
It's fine, it doesn't matter.
Track what you have on your screen with what I have on my screen.
Yes. Yeah.
So do you have log of 37 divided by log of 7? I'm sorry?
I put 7 divided by 3.
Then what did you do?
I just did 4 times 7.
Oh, that would be totally wrong. Sorry. Surprisingly, you ended up with the same number. But that should be wrong because you shouldn't be multiplying 4 times 7 first because you wrote it as this, right? You wrote 4 times 7. Yeah? To the power of x. It should still work because the order of operations should match. Sorry. There you go.
Oh. Mine's 148.0000.
So I'm wondering if you made a mistake here somewhere. Like log of 37 divided by log of 7. Yeah. Yeah. That's what happened to you too? Okay, so if that's the case, do this. Second function plus 712. Okay, do that and then try again. Log of 37, close the parentheses. Did you close the parentheses on 37?
Yeah.
Divided by log of 7, right?
Yeah. I didn't close the parentheses.
So I have 1.85564473. Yeah? Okay, let's store it. In x equals to 1.85644473. So we're going to do 4 times 7 raised to x, which I stored. I still get 148. What'd you get?
Oh yeah, now it's 1.
Okay, so something was off in terms of your calculator. Maybe it was in degrees instead of radians. It might be something small like that. So just reset if it seems kind of off, okay? All right. Here we go. Is the power by itself? Nope. So who needs to go? So I'm going to add 5 to both sides. Now, I am going to make a deal with you. If you can tell me something about this equation that we learned from the previous lessons, I will give you the shortcut method instead of the long way method with logs. Same base, meaning? Two to the third power. So I'm going to change 8 to 2 to the third power. And 4 can be changed to 2 to the second power. And what happens with my 3w that's already there? You multiply it. That's my shortcut. Because you have those tools under your belt, you can use that anytime you see possibility for staying base here. You know that 4 has a base of 2, 8 has a base of 2, and it can be written in powers of 2 and 3. Do it. If you can't, you want to see what it looks like? It looks like this. We would take log of both sides, put the 3w in the front, divide both sides by log of 4, just so that we can end up with log of 8 over 3 times log of 4, which is 0.5. You can still get there. You can still use this rule and get to where you need to go, but you don't need it to get to the same answer. So why use the harder way, right? So we got 2 to the 6w equals to 2 to the third power. What do we do? Same basis. Get it. Drop those bases, put 6w equals to 3. Be careful, please don't shout out. Think before you answer because we keep making these silly mistakes. What does W equal to? Okay, some of those answers are correct, some of them are not. We're going to be dividing both sides by 6, not looking for 2 or a third. This is 3 over 6, which is equal to 1 over 2 or 0.5.
If we put 0.5 in the test, would we be wrong? Well, I mean, she likes to put stuff in practice.
Since I allow calculators for this portion, either is fine. So we're gonna check. We don't need to store this, do we? Okay. We're gonna take 4 to the third power and we're going to multiply that by 0.5 or just 0.5 in your calculator. It'll still do the same calculation without the 0, okay? Then we're going to subtract 5 and see if that works. You ready? I'm gonna use my camera here. Handy dandy camera. All right, here we go. So what was it again? I think I'm gonna split view. 4 to the third times 0.5. 4 to the third power times 0.5. Close it. And then I need to bring it down to the normal level before I subtract 5. Okay? What do you get? 3. Yay. Is that what we wanted? Does this equal to 3 like it said? Yes, it does. 3 equals to 3. Yay. So this is correct. No extraneous. Y'all doing okay? I forgot to put no extraneous solutions for all of these. Okay. Are we good? All right. Ready? Number 7. I'm hoping this is the last one. Okay. Which one's the power with the unknown? 4 to the x plus 1, right? So I need to get rid of 7 and the negative. How do we do it? Do I divide by 7? Is that 7 times negative 4? You subtract 7 because this is a positive 7. Okay? So we're going to subtract 7 on both sides, and I get negative 4 to the x plus 1 equals to 11. How do I get rid of that negative there? You can multiply everybody by negative 1 or divide both sides by negative 1. Either way is fine. When I do that, I have 4 to the x plus 1 power equals to negative 11. That's not 11 minus 1, it's 11 times negative 1. Okay? Now what? Do we have common bases? Nope. So we do what? Log on both sides.
Where did the negative 1 come from?
You see that negative right here? That's a negative 1 times 4, right? So I'm going to multiply both sides by negative to keep that base a positive. Okay? So I have 4x plus 1 equals to log of negative 11. Okay? I'm going to move this x plus 1 to the front. We get x plus 1 in parentheses because they come together. Log of 4 equals to log of negative 11. Can you do something for me here? We're going to divide by log of 4 on both sides, but can you check something for me before I keep going? Can you put log of negative 11 in your calculator and tell me what you get? Anyone? It says error. And then what does it say as the reasoning? Not a real answer? Not a real number? Answer. Okay, so you cannot take a log of a negative number. Do you remember how the graph looked? The asymptote was at 0, x equals 0, right? Was there any negative inputs there? It was only all positives, right? You could have negative outputs, but you can't take negative inputs. So this is actually no solution, but I want you to finish this. So you can state this as x is equal to log of negative 11 divided by log of 4 minus 1, just so that you can say, this is my extraneous solution. Okay, therefore we have no solution. You can, but this would tell me that like if you just stop here, let's say, right? And you say, oh, no solution, great job, you get a 9. Because you told me exactly what you needed to know, right? Which was no solution. Still making it 9.5 maybe. But if you go all the way here, then I would say that's a 10. Because you really mastered it and you really know how to take that and fully express it to say it's an extraneous. Okay? Like I said, 9s and 9.5s are not wrong. They're just great. They're just great, not beyond great. All right, how are you doing? Is it time to go? Yes, it is. All right.